Talking about 2-7 parent functions and transformations. So let's read through this together. A lot of this is from geometry, and we're going to make it more of an Algebra 2 type of a concept. So the first thing you need to know is family of graphs. It is a group of graphs that display one or more similar characteristics. Then you have a parent graph. It's a graph of a parent function. So basically, this is the simplest graph in a family. This graph is transformed to create other members in a family of graphs. So in a moment, you're going to see what the parent graphs are, and we will be moving them to make new graphs. It's a lot easier than doing a t-table all the time. Translation moves a figure up, down, left, or right. Reflection flips a figure over a line called line of reflection. Normally it's over the x or y axis, but it doesn't always have to be that way. Dilation shrinks or enlarges a figure. Just like when your pupils dilate, it's the same thing. So here are our parent functions. You have to have these memorized. Basically, you're just memorizing the shape of these functions. The first one is a constant function, where f of x equals c. Remember, you could always call f of x y. It's the same thing. So for example, it will always go left and right. It will always be a horizontal line, and it will always be y equals something. That is a constant function. The next one is the identity function, f of x equals x. So the line y equals x, if you go back to Algebra 1, is just this line. It starts at 0, 0, up 1, right 1, and that's the identity function. Absolute value function, by now you should realize that it's going to always be a V shape. So the parent function of the absolute value function has ordered pairs 0, 0, 1, 1, negative 1, 1, etc. Quadratic function is going to be a U. It's a parabola. So 0, 0, 1, 1, negative 1, 1 again. So these four functions are what we start with, and we're just going to be moving them up, left, right, and down. You might be making them a little bit fattier, skinnier, all that kind of stuff. We'll get into that in a second. You need to copy down the chart on page 112, or you can write mine down. It's all the same thing. Right now, this isn't going to make sense yet. It looks very confusing, but once I get into the examples, you'll see that it's really not that hard. So the first one, f of, if it's inside the parentheses, you're going to move left or right. You're going to go opposite of the sign. Opposite sign. So for example, this has a plus sign, so you're going to move left. This has a minus sign, so you're going to move right. If it's outside the parentheses, like these two, it's going to be the same as the sign. It's going to be up or down and the same as the sign. This is a plus sign, so you go up. A minus sign, so you go down. The rest of these, we usually do a t-table to figure them out because it's really hard without one. However, negative f of x reflects over the x-axis. F of negative x reflects over the y. Again, we'll do an example. If you have a number in front, if it's not a fraction, so greater than 1, it stretches vertically. If it is a fraction, it compresses vertically. Then if you have a number inside like this, same rules, compress horizontally, stretch horizontally. Again, that's not really going to make sense yet. At least write it down because later it will. So take a moment, pause, write everything down, and we'll do some examples. Next, right now all I'm asking you to do is identify the type of function. So all I'm asking is which one is a parabola or a quadratic function, which one is the constant function, the one from the parent graphs from before. That's it. So take a second, pause it, see which one is which. Letter A, this is the absolute value function. It makes a V, so it's absolute value. Letter B, this is the constant function. It's a horizontal line, so it's our constant function. Letter C, this is our quadratic function. It's a parabola, it makes a U, it's quadratic. And letter D, this is our linear function, or you can call it the identity function. It's the same thing. This is our identity function. And that's it for that kind of a question. You just have to be able to recognize which shape goes with which function. All right, some examples. Number 2, graph y equals the absolute value of x plus 2. You can do a t-table. You can always do a t-table. The problem is it takes a lot of time, and I think you know from your homework already that sometimes negative 2 to 2 isn't enough on the t-table. And you have to do even more, and it takes forever. So if you go back to our rules from here, okay, on our example, the 2 is outside of the absolute values, or eventually we'll get into square roots or parentheses or whatever. So if the 2 is outside, that looks like one of these. So it's going to be up or down, the same as the sign that we have. So this is going to be up 2. So you take our original problem, don't write this down yet. Here's our original absolute value equation. That's how it usually looks. Okay, and I'll graph our final one in red, or some color I can find here. Okay, so this one is going to take that function and it just moves the whole thing up 2. And that's it. If I say sketch a graph, that's good enough. All you have to do is just go up 2 and make a V. And that's fine. Just make sure it looks like a V and not a U. However, if you really want to and you want to make it perfect, you can do a t-table from negative 2 to 2 or whatever. Right now I'm just going to do negative 1 to 1 to save some time. Negative 1, absolute value is 1, plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3, which is exactly what I have. Negative 1, 3, 0, 2, and 1, 3. And that is your graph. So again, right now we're just focused on sketching graphs, so we don't need to be perfect. This is good enough. Number 3. Graph y equals absolute value of x plus 3. The 3 is inside the absolute values. So if you go back to our rules, it's inside. I understand these are parentheses, but it's parentheses or absolute values or a square root sign or whatever we end up getting. If it's inside, it's going to go left or right, opposite of your sign. So if we go back to our problem, it's inside and it's a plus sign. So would that be left or right? This is going to move the graph left 3. So my original graph looks like this. You do not have to graph the original one. I'm just trying to show you our original graph. And again, I'll get a different color for our final answer. So if I move this left 3, you just go 1, 2, 3, put a dot, and graph your line. If you really want to, you can do a t-table. I'm not going to go from negative 2 to 2 because that's not really going to help me. I know that negative 3, 0 is my first one. So I'm going to put, sorry, this should be a negative 2. I'm going to put these ordered pairs in instead. Negative 4 plus 3, absolute value is 1. Negative 2 plus 3, absolute value is 1. So negative 3, 0, negative 4, 1, negative 2, 1. So no matter what, if I just ask you to sketch the graph, you just need to know that it's your V that just moved left 3. And that is good enough. Number 4, graph y equals x squared minus 4. So let's go back to our original problem. The parent graph of this is x squared, which we already know looks like this. This is our parent graph. So if it's minus 4, not inside of here, that's going to be down 4. So if you're just sketching it, you can just go down 4 and that's it. So 1, 2, 3, 4. Here's our final answer. If I said actually graph it, you could do a t-table from like negative 1 to 1, and you're going to get these answers. I'm going to go back and do another one. I want to make sure you have a really good example. So let's do another one right here real quick. Well, I don't know, 4a or something. If I had done y equals x minus 2 squared, it's the same idea. If it's inside parentheses, inside absolute values, inside a square root sign, whatever it is, it's going to be left or right, and it's going to be the opposite of the sign. So what does that mean? Right 2. So a quick sketch of that graph. Your original graph is right here at 0, 0. So you just move the whole thing right 2. And that's it. Again, t-table is fine. When you have a negative, it gets a little bit confusing. If you look at number 5, graph y equals negative x squared, and if you look at number 6, graph y equals negative x, they both kind of look the same. So to me, if you ever have a negative, you're not quite sure if it flips over the x or y axis, let's just be safe and go ahead and do a t-table. I'm only going to go from -1 to 1 for right now, and then we'll keep going from there. So take a minute, pause this, and do a t-table. So if we were to put in -1, order of operations, -1 squared is 1 with a negative in front. If we were to do 0, well, that's just 0, so that should be easy. If we were to do 1, -1 squared, order of operations, 1 squared is 1 with a negative in front. So our answer is going to flip over the x-axis. So the original looked like that. Our answer flipped over the x-axis. Number 6, again, I just think a t-table is safest. So we at least know that the parent graph looks like this. Again, you do not have to graph it. I'm just trying to show you that. So let's do a t-table from -1 to 1. Take a moment, pause the video, and do it yourself. So if I do -1, absolute value of -1 is 1, with a negative still in front, so -1. 0, well, it's just 0. 1, you have a negative. The 1, absolute value of 1 is 1 with a negative in front. So this one, if we graph it, -1, -1, 0, 0, 1, -1, is going to do the same thing as the last problem, and it's going to flip over the x-axis. So our final answer is this one down here. Graph y equals 4x. Something like this, you can go back to the parent graph, which is this one, the identity function, and you can move it if you want to. But to me, that's in slope-intercept form. If you really want to look at it that way, it's so easy. You just start at 0, and you go up 4, right 1, and you just graph the line. I don't think you really need to do transformations with something that is slope-intercept form. I think that's easy enough on its own. 2x squared. This is the one where I was telling you if there's a 2 in the front, it's either going to get fatter or skinnier. So it's nice if you can memorize what's supposed to happen, but you don't know how fat or skinny it's going to get. So we have to do a t-table no matter what, because we don't know how wide or skinny this is going to get. So again, our original function, you do not have to graph it, looks like that. So let's go ahead and do -1 to 1. Take 2 seconds, pause it, do a t-table. Okay, so y equals 2x squared. If I do -1, what's -1 squared? 1, so you get 2. 0 squared times 2 is 0. 1 squared times 2 is 2. So our final answer is -1, 2, 0, 0 still, and 1, 2. Do you see how this was skinnier than the original problem? So let's go ahead and do 8a. Y equals 1/2 x squared. What do you think is going to happen? Fraction fat. If there's a fraction in front, it's going to get fatter. So let's do -1 to 1 again. Pause the video, do it yourself. So -1 squared is 1 times 1/2 is 1/2. So 0.5 is fine. 0 is still 0, and you're going to get 0.5 again. So I'm going to do this one in red to show that it gets fatter. So -1 and up just a half. 0, 0 still, and 1 up a half. Do you see that this one got fatter? So fraction in front, fat. We're talking about numbers, not people, so you can say that. And then if it's not a fraction, it gets skinnier. So if I asked you to sketch a graph, you could just show me that it gets fatter or skinnier, but the problem is you don't know how fat or how skinny. So if it has a number in front, you have to do a t-table. Have to, have to, have to. For all the other ones, if you can memorize it, you can just say left, right, up, down, and move it that way. So let's do one more. Let's make it a little bit harder. I guess this would be number 9. Let's make one up. Let's see here. X minus 2 squared plus 4. Let's do that one. Take a second and see what would happen to the graph. We're just going to sketch it, so you don't have to do a t-table unless you want to. Whenever I do these, I like to write down what's going to happen. This means right 2, and this means up 4. So I know that because this is a square, it's going to be a U. So I move right 2, up 4, and I go ahead and put my dot. Did I say a square? Sorry, I know it's going to be a U. It's going to be a parabola. I don't remember what I said there. And that's all you have to do. If you really want to, do a t-table. Why don't you try 9a? Let's do x plus 1. Try that one. So this means left 1 and down 2. So you take your v and you go left 1, down 2. And you just make your v. That's it. One more. So number 10. Y equals negative absolute value of x plus 4 minus 1. You try it without me. This means flip, this means left 4, and this means down 1. So I know it's a V, so I go left 4, down 1, and it flips. But again, if you need to do a t-table, feel free to do so. Take a moment, write anything down that you need to. If you have any questions, please let me know. I know this is new for you, so it's a little bit different. It's a little bit harder. But if you think about it, left, right, up, down, that stuff is pretty easy. The flipping it and the fat or skinny gets a little bit harder. So when you get back to the rules, if we go back up a little bit here, these and these should be pretty easy. For most people, these are okay as well. These, no matter what, you need to do a t-table. So write down any questions you might have and let me know.